Hello. Now we are going to look at construction 22. And construction 22 is the construction of the orthocenter of a triangle. So the orthocenter is one of the centers we have to know about for our triangles. And it's important that we spend some time thinking about the name of it so that we can remember which one we're talking about in the exam. Because it'll just say, draw the orthocenter, and we need to know which construction we're talking about. So an anchor we can use is that ortho means at 90 degrees or perpendicular. So when we're talking about the orthocenter, we're talking about getting the perpendiculars off of the sides of our triangle going through the far vertex. So where have we seen a perpendicular off of a side going through the far corner or the far vertex? Well, we've seen it for the perpendicular height. So if we're looking for the perpendicular height of a triangle, say when we would be, like in this situation here, we'd be gathering information for getting the area of that triangle. We'd need half the base times the perpendicular height. Well, that perpendicular height line, where we are perpendicular to the base, the side of the triangle, going up through the far vertex, the far corner, that line that we're used to looking for the area formula is the line we are looking for here. So that right angle from a side is the ortho part of the center. So that's what we're looking for, and that can link it into what we already know. The formal name for this perpendicular height line is an altitude, which can be helpful because altitude is something we would have heard of as a height before, particularly when we think about aircraft. How high is a plane flying above the ground? What we mean more specifically is if we go perpendicularly up from the ground at normal, the normal to the ground, I should say, in 3 dimensions, how high do we go up to get to the airplane? That's its altitude. So we're used to the idea of the perpendicular height and the altitude maybe being a connected idea. Mechanically, what we are going to do, and particularly if we wanted to do this algebraically, we would be getting the intersection of 2 lines, and my first line here is going to be L1. It's going to be perpendicular to BC. So BC is the base or the side length that I'm going to work with. And I want the line to also go through A. So perpendicular to a side going up through the far vertex. Again, what we already know about finding the perpendicular height for getting the area is exactly what we need in mind. Where 2 of those lines cross each other, we call that the orthocenter. So there's 2 ways of constructing this, and we're going to go through both of them. So the first one, the more formal one, is when we want to get, if we think about what we want to get, we want to have a perpendicular to this line here going through a point A, which is not on the original line. Well, that's actually a construction that we have already done. So the way that we do it is we open up our compass so that it reaches down to from A to our line segment BC, and we draw a little arc across there and keep the compass the same size and draw a little arc across there. And what we do now is get the perpendicular bisector of this little line segment between these 2 arcs. Now, depending on the shape of your triangle, this can actually be a little bit awkward to do inside the triangle. There's nothing that stops you from continuing the line BC out here and making arcs at a wider section. I'd run out of space on my little screen, but if you structure your page carefully, you would be able to project this out so that you get arcs that crossed more nicely. Crossing it such a severe diagonal here can make it difficult to do things accurately. So you can project your line out and get the perpendicular bisector of where those arcs cross, and that will inevitably go through A. So that is good to practice. So we have now got to take the perpendicular bisector of where our arcs are crossing BC, and we are expecting that to go through A. If we've done our construction right, it will. So open up the compass. I'm going to change the color to keep track of what I'm doing. And we are going to open up more than halfway between our arc crossings. And we are going to just bring this up a little bit so it's further out of the way. Make sure we can get down there. Yep. So we are going to draw our arc up here. And we're going to swing our compass around, and we're going to do the same thing down here. It's not a great idea to have continuous arcs going here. It makes the construction very messy. If you really want to, there isn't anything technically wrong with it, but it makes it difficult when there are so many squiggles on our page to keep track of what it is we're doing. So we keep the compass at exactly the same size, and just do a perpendicular bisector. There's nothing unusual to it. It's just a perpendicular bisector. So where those two x's cross each other should go straight through A. So I'm actually going to put my straight edge at A and judge that. Is that going straight through my x's? And it is. So it's a way of knowing that my construction went correctly. When I go through those two crossing points, I have to go through A. If I don't, something went wrong. So that's a good way to know whether we need to go back and have another look at what we've done. So I am going to change color so we can see everything we've got. So that is going to be one of our orthogonal, that's going to be one of our altitudes, our perpendicular height lines. So what we know about that is it is at 90 degrees to BC, that's going through A. So that length of that point there, of that line segment there, is going to be the perpendicular height from the base BC. Now that's the formal way to do that. And it's important that we be able to do it that way. It is usually accepted that you are able to do this using a set square as well. So we're going to now take our set square and we're going to do it the other way. So I'm going to have my perpendicular from AC going through the far vertex of B. So I'm going to rotate my straight edge around. And it's best practice to sit. It's difficult to keep track of the set square being square to or being in line here and also lining up with B. So it's better to take a ruler and use it as a kind of a railway, like if we were doing a parallel lines with a set square. So bring that around so that it's in line. So that it's in line with our ruler. Make sure our ruler is along AC, and then we're going to slide along the ruler until we're in line with B. Be as neat as we can. When we've gotten that to align correctly, so we are going through B, we draw in our orthogonal. Sometimes this can end up outside, so you may need to extend it past the triangle, but in this particular case the crossing is inside the triangle. So in this case what we have done is get our 90 degrees to our far side, to AC, and we have gone perpendicularly then through the far vertex of B. So in both cases we're just getting the perpendicular to a side through the far vertex. And again, it is important to tell ourselves the story of that as we're doing these constructions. So we have now gotten our point, our orthocentre, which we had labeled as D. We could also get the orthocentre from by getting the perpendicular to AB through C. It will go through exactly the same point. So if we had to do this algebraically, we would be getting the information we would need for getting the equation of a line would be perpendicular to a side and then going through the far vertex. And that would give us the information we need for the equations of our lines L1 and L2. So we have L1 is our purple line that we did first using our more formal construction, and then we can also, it is generally accepted that you can use a set square. They can tell you not to, so you do need to know how to do the perpendicular to a line segment and through a point that's not on the line. So we need to know both methods. Both methods are different forms of construction that we're required to have. So that is how we can create our orthocentre, and that is what we need for now.